Welcome to another episode of AI Talks with Chris and Nita. Today, we're diving deep into something pretty fundamental for AI. What happens when you need an AI to learn something totally new, but you barely have any data? Because let's be honest, getting those huge, perfectly labeled data sets, it's often super expensive or sometimes just impossible in the real world. So our mission for this deep dive is to unpack three really interesting ways AI is tackling this. Zero shot, one shot, and few shot learning. And these aren't just jargon, right? They're actual pathways to making AI more adaptable, more efficient, really more useful in tricky situations.
Exactly, and that's why they're so crucial. We need these techniques to deploy models out there, where you can't just grab massive data sets. They're hitting AI's big challenge head on. How to generalize, how to learn from just a little bit of information, sometimes almost none.
Okay, let's unpack this. Zero-shot learning. The name itself is kind of wild. How does a model learn with literally zero examples of something?
Yeah, it sounds a bit like magic, doesn't it? But ZSL lets a model recognize and classify things it has never encountered during training. It doesn't use visual examples for the new stuff. Instead, it relies on things like semantic information, textual descriptions, lists of attributes, maybe embeddings. The core idea is mapping both the input, say an image, and the possible labels into a shared meaningful space, like a semantic space. So when something new comes along, the model compares its semantic features to what it already knows and makes an inference. It's kind of like reasoning by analogy.
Okay, that's clearer, but can you give us a concrete example? That usually helps nail it down.
Sure. Let's say you train a model only on pictures of cats, dogs, and horses. It knows them well. Then you show it a zebra. Never seen one before. But if the model understands attributes, has stripes, four legs, looks kind of like a horse, it can piece together, based on those descriptions, that this new thing is likely a zebra. It's classifying based on understanding characteristics, not just visual memory.
That's really cool. It's tapping into a deeper, almost language-based understanding. And you mentioned embeddings. Are things like BERT or clips involved here?
Spot on. Techniques like embedding-based learning are key. Using models like Word2Vec, Glove, or BERT, they turn words and concepts into numerical forms that capture meaning. Attribute classifiers are also big, and then you have powerful combos like OpenAI's CLA, which learns to connect images directly with natural language descriptions. And that's why ZSL powers things like text-to-image generation. Think DLA, you describe it, it draws it. Or classifying things with huge vocabularies, visual Q&A. It's got pretty broad applications. The challenge is just getting those descriptions right,
Right, ensuring the semantics are rich enough. Okay, so zero shot is mind-blowing. What if you do have one example? Just one single picture or data point. Does that change the game?
Oh, absolutely. That brings us to one-shot learning, or OSL. Like the name says, the model learns a new category from literally one labeled example. Super useful when getting even a few examples is hard or costly. How it works is a bit different, though. Instead of trying to learn deep features from that one example, which is risky, OSL often uses meta-learning or similarity learning. It focuses on learning a comparison function. How similar is this new thing to the one example I saw? It learns relationships, distances, not just features. Like a kid sees a picture of some weird animal, maybe a platypus, just once. Later, they can often spot another platypus because they grasp the key platypusness from that single image. OSL models try to do something similar.
That's a great way to put it. So what are the key techniques here? I think I've heard of Siamese networks.
Yeah, Siamese networks are a classic for OSL. They take two inputs and learn to judge how similar they are. Perfect for comparing a new item to your single known example. There's also triplet loss, prototypical networks, matching networks. They're all essentially about learning good similarity metrics. And this is why OSL is huge in facial recognition, matching a face to a database entry, or signature verification, handwriting analysis, even in medicine, maybe identifying a super rare condition from just one available image. The risk, of course, is if that one example is weird or unrepresentative.
Yeah, that makes sense. Okay, so zero examples, one example. What if we have just a few? Still not many, but more than one. Few shot learning.
Exactly. Few shot learning, FSL, is basically a broader version of OSL. Here, you learn from a small set of labeled examples per class, maybe like 2 to 5, or maybe up to 10, something small. It tries to find that sweet spot, between needing hardly any data and still being able to generalize well. Like OSL, it leans heavily on meta-learning. The model learns how to learn quickly from new small data sets. It's often trained on lots of different small learning tasks called episodes, so it gets good at adapting fast. Think about classifying bird species. Instead of needing hundreds of photos of a new bird, an FSL model might get the hang of it after seeing just, say, 5 labeled pictures.
Wow, that really accelerates things. It's like teaching the AI to be a quick study. So what are the go-to methods for that?
Yeah, learning to learn is the core idea. Meta-learning algorithms like AMML, model-agnostic meta-learning, are designed for this rapid adaptation. They basically learn good initial parameters that can be fine-tuned quickly. We also see a lot of few-shot fine-tuning, especially with big pre-trained models like transformers. You take all that knowledge and just tweak it a bit with your few examples. And that episodic training structure is key for teaching this adaptability. This stuff is really powerful for personalization, adapting a model to you quickly. Or in NLP, using prompts to fine-tune models. Robotics too, adapting to new objects or environments fast. So, just to quickly recap the main difference, zero shot, zero examples, relies on semantic descriptions for totally unseen classes. One shot, one example, uses similarity or metric learning for new classes that are somewhat related. Few shot, a handful, like 10 examples, uses meta-learning, leveraging past learning experiences to adapt super fast.
Okay, that clarifies the spectrum nicely. So bringing it all together, what's the big picture impact for us, for the listeners, and sort of the future direction of AI?
I think the main takeaway is that these approaches, ZSL, OSL, FSL, are tackling a massive bottleneck in AI. The dependence on huge data sets. It's not just about saving money or time on data collection, though that's huge. It's about making AI fundamentally more flexible, more adaptable. We're shifting from models that just memorize patterns in big data to systems that can leverage knowledge, descriptions, similarities, learn more efficiently. And this unlocks AI for all sorts of niche problems, personalized applications, situations where data is just naturally scarce. It makes AI much more practical for the real world.
That really does sound like a significant shift, making AI less brute force data dependent and more, well, intelligent in how it learns. It feels closer to how humans manage to learn new things so quickly.
It does move in that direction and leads to a really interesting thought for you, the listener, to chew on. As these models get even better, blending transfer learning, embeddings, meta-learning, what could AI achieve if it truly mastered learning from just a description? Or only a couple of examples? What completely new things could it learn? What frontiers could it explore with that kind of efficiency? The potential feels vast.